right, so we've got number 18 here. It says the prism in the first octant bounded by z equals 2 minus 4x and y equals 8. Okay, cool. All right. So my first step when attempting these problems, I'm going to define my R3 simple. And we're basically choosing the first variable to integrate with respect to. I'm going to do z. Z is typically a good simple to start with, unless there was a bunch of like y equals stuff like over here, then I would choose y. You can choose y here, but I'm just going to choose z simple. So I'm basically finding the bounds for it. So if everything is in the first quadrant, this has to be 0 here, and z goes to 2 minus 4x. All right, perfect. So then for step 2, we're going to define our region. Make sure I'm recording. Yeah. We're going to find our region, which is on the xy plane. Right, because we chose z simple first, so we're going to be looking at the region on the xy plane. So we do have to draw this. This is a pretty necessary step in order to know. The drawing's not too hard. Like it's pretty chill. I was intimidated by it like at first, but it's pretty straightforward. Okay, cool. So they have in the problem that y equals 8, and then x, we can just set z equal to 0 to find the x in this problem. So if we set z equal to 0, we're going to get this, and move the 4x over here, you're going to get x equals 1/2. All right, so I'm going to put 1/2 like right here. Picture is not to scale, but it'll do. And then we basically found our region. This is where it is. And these here intersect at the point 1/2, 8. All right. Looks good. So now y is going to be bounded from 0 to 8. And our x is going to be bounded from 0 to 1/2. Perfect. All right. Now I can move on to step 3, which is the setup. The setup is definitely the most challenging part to these problems, but with enough practice, you'll get better at it. And because after that, it's just integration at that point, and the integration is pretty straightforward for this problem. So let's go ahead and set up our integrals. And we chose z simple first, so that's our first variable to anti-differentiate with respect to. And then I'm going to do dy dx. You can do dx dy. The order doesn't matter here because we're dealing with a rectangular region. But I'm going to choose dy dx first. This is going to be z, which is from 0 to 2 minus 4x. Those are the bounds we found. Y is going from 0 to 8, and x is going from 0 to 1/2. And this matches with that, same with that. Yep, all looks good. All right, perfect. So if we go ahead and start, we're going to do 0 to 1/2. That's for the x's. We're going to do 0 to 8. And since the problem didn't give us a mass density function, we're safe to assume this is 1. And if we're if we're integrating with respect to z, we're just going to get z. And that's being evaluated from 0 to 2 minus 4x. And we have a dy dx still sitting here. Okay, so plugging that in, you're going to get this function here, 2 minus 4x dy dx. Right, because we're plugging 0 to 0. Okay, so if we keep going, 0 to 1/2. And now we're integrating with respect to y. So we're going to get the 2 minus 4x. That's all one big constant. And then y gets tagged on there. It's being evaluated from 0 to 8. We have dx. Okay, so then now we're going to have this integral from 0 to 1/2 times 2. No, not times, sorry. 2 minus 4x times 8. There we go. Dx. Okay, let's simplify it a little bit more. We're going to end up getting this integral from 0 to 1/2 of 16 minus 32 x dx. Perfect, looks good. If we keep going, we now integrate with respect to x. We're gonna get 16x minus 32 times 1 over 2 x squared. And that is being evaluated from 0 to 1/2. We're gonna get, if we plug it in, it's gonna be 16 times 1/2 minus 32 halves times 1/2 squared, which is 1/4, and minus 0. Yeah, looks good. All right, perfect. 16 times 1/2 is 8, minus 32 over 8. And we can rewrite it as 64 over 8 minus 32 over 8, and get 32 over 8, which equals 4. Boom. All right, and you don't have to write this, but 4, this is the mass of your 3D region. Ugly 3D region. Okay, yeah, that's your answer right there for you. Thanks for watching, you guys, appreciate it. And I mean, let me know if I did anything wrong. And if you have any other questions, I could try to answer it for you. Good luck.